Hey guys, what's up? Welcome back to the Python Fundamentals series on data types. In this second video of sequence types, I'm going to talk about lists. So lists are a fairly regular use data type in Python, and I think they're very handy. And I think this is especially important of a chapter if you want to deal with medical images, since medical images are nothing but 2D or 3D arrays. And with the usage of the numerical Python or NumPy library, they get treated a lot like lists. So understanding syntax, indexing, and properties of lists, I feel like is essential for medical image processing. So I have here two example lists which both contain integer numbers, like I just randomly made them up. And I have some bullet points I want to talk about first. So if you have a random list, in this example it's our example list, which is very creative. And we wanted to check if a specific number exists in this list, you could go about it like if two in example list print 2 exists in our list. If we run that, sure enough, it gives us our printed statement because 2 exists in our list. If we plug something in that doesn't exist, like 56, and we run that again, there's no print popping up. That's because the if condition never evaluates to true, and therefore it doesn't exist. So something very often needed with lists is adding items to a list, whether that be through a loop or just statically adding another portion of elements to a list. And the easiest way is the .append method. So let's call a variable a just for simplicity, and we wanted to assign a to example list. Actually, no, let's not assign something new to it. Let's just print our example list, and then afterwards we print our example list, but we append, I don't know, 14 to it. And then if we run this, we can see that it returns none. So what happened here? To understand better what happened, let's keep the print statement of our original list and just append the number 14 to our list, and then afterwards this is evaluated. Example list, then we print the list again, and now you can see we now have the number 14 added to our list. This is an interesting property, since the .append method doesn't have a printable or return value, or it doesn't have the return value that we're expecting. It just returns none. So if you guys work with that, be sure that you either reassign the list or just simply use the .append method. So if I were to loop over something and I were to append the loop index, so say for I in range of, I don't know, 20, example list .append I, you would go about it like this. And it is important that you keep in mind how this functions. So I'll print it before the loop and then after, and let's see. And as you can see, after we run it, we have our original items in the list, and then we added all the different stages, or different iterations, from 0 to 19, so 20 new elements to our list. And this is how you would go about it. If you had an empty list, you wanted to append something, you would have to go empty list. You have to first tell the interpreter that there's a list, so you have to declare it first. And you then can print it, and let's print it out after. This one we can delete. We go, and run that. And sure enough, it contains all the numbers from 0 to 19, which is what we would expect if we added the numbers from 0 to 19 to an empty list. Now, Another method we could use is the insert method. And what's neat about the insert method is you can decide at which spot the element you want to insert gets inserted. So let's go back to printing our original example list. And if we were to example list dot insert, so first I think you have to give it the position. So that will be, let's do position 2, and we want to insert the number 3. Okay, oops, now if we run this, now our list contains the number 3, which previously it didn't. I left it out on purpose just to demonstrate the insert method, the dot insert method. And it is at position 2. So again, I've talked about this in the previous video. The way indexing works in Python is it starts at 0. So you have to keep that in mind, because the first element is the 0, the second is the first element, and so on and so forth. So we inserted our number 3 in the second position of our list. Now, another way you could add elements to a list, especially from a different list, is the .extend method. And for that, you just type, let me delete that real quick, extend, there you go. And we want to extend our list with the elements of the second list. So we would go element second list. And again, let me keep that clean. And we again run and print this. As you can see, here's our original example list. And after we extend it with the second list, we don't just have the original elements, but also the ones from our second list. So .extend works exactly as you would think. It just adds the elements of another list to the end of the first list you call the method on. Okay, so let's go to removing elements from our list. This is also something that you probably be using throughout your throughout your time you're working with lists, I guess. And to do that, you could do something. Actually, let's keep this example here. Let's move it down. And if I were to get rid of a specific element, I could just use the .remove method that I've used in previous videos. And for that, I have to give it the element that I want to remove. So say I want to remove 1 from our list, and I run this. It removed the first element, in this case, the number 1 from our list. So this is sort of element sensitive, so you can pass it a specific element. Now let's try what happens if we want to remove something that doesn't exist in our list, like the number 14, and we ran this. It gives us a value error. So if you want to remove a specific element from your list, you should be sure that it does exist in the list in the first place, or otherwise you'll run into an error. This is something you have to keep in mind when you use this method. The second one I think is interesting or helpful when you want to remove elements from list is the pop method. Again, I've used this before. It works on several different listing data types in Python. And if I just left it like this, the pop method gets rid of the last element in our list. So if we run this, it got rid of the number 9, which is the last element. You can also tell it to remove a specific element. So if I wanted to get rid of the second to last element, like this, and I run it again, it got rid of the number 7. And this is especially helpful if you have some properties that have to do with the order in which elements were added to your lists. Then the pop method comes in handy. However, it is not sensitive to the specific number. It just gets rid of the element at the position. So to sum up, remove, you can get rid of a specific element in a list. However, it has to exist. And the pop method allows you to get rid of an element at a certain position in a list. Okay, so good so far. So far, so good. The length of the list you can determine as we did before with the length function. You just do lang of example list, and let's print that to see what it gives us. And it's 7, and it's exactly the number of elements we have in our list. Let's try if it works with the second list as well, and it gives us 3, which is the number of elements we have in this list, so it works pretty straightforward as you would expect. Now when it comes to copying lists or reassigning a list to another list, you have to be a bit careful. since the assignment operator just references one list to another, and that means that changes made to one list will automatically be also made to the other list. So if we go, I don't know, list 1 equals list 2, and let's say list 1 has existed before, then every manipulation you do on list 2 will also happen on list 1, since it's just a reference and not a new sort of instance that gets created in RAM of your object. So that's something you have to keep in mind. The way you can get around that, there's certainly cases where I could think of that would make sense to use this property, but most of the time I feel like it's more annoying than it's helpful. And one way to get around of this is you could either call the list constructor on it. So we could go with our example list. Let's print that actually to again see if it's stayed as we expected. And you could go about it like this, where you make a second list. Let's call it listy2. I'm really running out of creative names for for lists. And if you call the list constructor, which you do like this, and you pass it in the example list, it creates a second instance of the example list and not just a reference to it. Let's see if this really holds true. So let's do a manipulation on list2. Listy2, sorry. Let's pop an element, and then again afterwards print both lists so we can check if the changes only happen to the list we are expecting the changes to happen to. Alright, let's run that. So the first print is our example list, which makes sense. Then we call the list constructor on example list and assign it to listy2, our new list variable. Then we pop the last element of listy2, we print both, and sure enough, the original list stayed as it was and the second list got diminished by one element. Now, another way you could do this is the .copy method, where, let me keep the prints here actually. We could go listy2 is example list .copy. And this also tells the Python interpreter to create a second instance of the object example list and reassigns it to this name, which also helps you to avoid manipulation of the list you want to keep as it is. So if we run this, oh, I didn't make any changes to listy. That is stupid. Then again, run. Let's do a pop again. So get rid of the last element. Pop, not poo. And sure enough, again, it got rid of the last element. However, only in our second list, which became a separate instance because of this .copy method we called on example list. Now, 3 methods I want to talk about in the end that are pretty handy for dealing with lists are reverse, sort, and count, and they do pretty much what you would think they do. So if we were to print example list dot reverse, and we ran that, it returns none again, because I forgot that I have to perform it without the print operation because the return value is not very helpful in this case. So actually let's print the list before again, and so we can directly see what changes occurred. And then after we reverse the list. So if we run this and print it, you can see this is our original list, and after we've reversed it, it happened exactly what we expected to happen. It reversed the number of elements in the list. Okay, sort does also exactly what you would expect it to do. It sorts the number of elements in the list. However, mine is a bad example because they're already sorted, so I have to change something up here to make it clear that sort works, and let's put the 2, I don't know, here. Yeah, like this. And if we then change this function to sort, to go and run it, you can see this is now my newly changed unordered list, and the sort method did exactly what you would expect it to do, which is sort all the elements. And the last one, count, I think you can imagine what it will do. This one you can call in the print, I believe. So let's go like this and print it. I have to give it something to count, so let's count the number of occurrences of the element 2, and if I print this, it will give me 1 because there's 1, 2 in our list. So this is pretty neat if you want to count how many times the element does appear in a list. And that is something that is redundant in sets, as you can imagine, since sets only carry one occurrence of a specific value within themselves. Alright guys, that's about it I wanted to talk about with lists. If you liked the video, please leave a like and subscribe to the channel. This helps me. And other than that, I hope you guys are having a great day, and I'm looking forward to seeing you in one of my upcoming videos. Peace.